Welcome to the first video in Chapter 6 on determinants. So Section 6.1 is an introduction to determinants, and that is indeed the goal, to introduce determinants and motivate their study. In Chapter 5, we saw that if we had a 2 by 2 matrix A, which is A, B, C, D, it was invertible precisely when the quantity AD minus BC was not equal to 0. This single number that's calculated from the entries of A lets us determine whether or not A is invertible. We call this number, this AD minus BC, we call this the determinant of A. If all matrices were 2 by 2, there'd be little else to say, but of course they're not. So the goal in this chapter is going to be to extend the determinant to matrices of all sizes. So n by n matrices for any natural number n. We're going to define the determinant of an n by n matrix A as a number calculated from the entries of A, like above, but in a precise way. In fact, we're going to learn several methods to calculate this number. And perhaps most importantly, the determinant of a matrix A will continue to have the property that A is invertible if and only if its determinant is non-zero. The link to matrix invertibility is arguably the most well-known characteristic of determinants, but this is actually not how they first arose. They first arose when people were learning to solve linear systems, particularly to figure out when a linear system had a unique solution. In section 6.3 of this chapter, we're going to use them to do that as well. Matrix invertibility, linear systems, these are only two of the ways in which determinants are used. They arise in calculus, in algebra, and geometry. So if you continue to study mathematics, I'm sure you're going to meet determinants again. So the takeaway, the determinant of an n by n matrix A is a number that is calculated from the entries of A and whose value is non-zero exactly when A is invertible. So in the next these determinants, how to calculate them, and their properties even further. See you then.